All right, let's take a look at the units of temperature. So we have different units, just like for mass, you have the gram, the pound, the ounce. For temperature, we also have different units. The one that you're probably most familiar with is degrees Fahrenheit. So this is, the unit temperature used in the US and some other countries as well. Nothing really wrong with the unit or anything like that. Then we have degrees Celsius. This is the one that's used in most of the world. So I'll say rest of the world. And it's the one that's used in science. So we as scientists use degrees Celsius. We rarely use degrees Fahrenheit. You will find, here and there use degrees Fahrenheit, but degrees Celsius is more often used. And just to give you kind of some relations, right, in degrees Fahrenheit, water freezes at 32 degrees Fahrenheit. So if you live, in some place that it gets that cold, if it's below 32, we might see some snow. Southern California, we don't really deal with that too much. It boils at 212 degrees Fahrenheit. A lot of people think water boils at 100 degrees Fahrenheit, right? That's not true. Otherwise, we'd all be dead on a really hot day, but it just sounds like a nice round number. And then the same kind of things for degrees Celsius. So water freezes at 0 degrees Celsius, and then it boils at 100 degrees Celsius. So you can see that the Celsius temperature range was based off of water either freezing or boiling, whereas the degrees Fahrenheit range was based on some other things. It's the 0 is based on the freezing point of salt water, and the 100 is based around approximately human body temperature. We can, of course, convert from one to the other. So degrees Celsius is equal to degrees Fahrenheit minus 32 divided by 1.8. I personally won't ask you to do this conversion, but you may see it in some of your other classes, or maybe you take Chem 101, then you probably will be asked to do this conversion. All right, but both degrees Fahrenheit and degrees Celsius, they have a problem when we're thinking about them through a scientific lens. And that problem is that 0 isn't 0, right? So what does that mean? 0 isn't 0. Of course, 0 is 0. So what does 0 isn't 0 mean? So let's take a look at mass. If you have 0 pounds of something, I'm just going to say 0 pounds of, I don't know, sugar, I guess. How much sugar do you have? Well, you've got none. You've got 0 pounds, so you've got 0 amount of sugar. So let's take a look at the same question with our units of temperature. If you have 0 degrees Celsius or degrees Fahrenheit, whichever one, of thermal energy, because remember, temperature is the measure of thermal energy. How much do you have? Do you have 0 thermal energy? And the answer is no, you do not have 0 thermal energy. You actually have more than 0 units of thermal energy, right? More than 0 joules of energy. And so 0 isn't 0 here. 0 doesn't mean that we have no thermal energy. 0 was just arbitrarily chosen as the temperature, that water freezes or that salt water freezes, but that's totally an arbitrary thing, and we can get colder than 0 degrees Celsius or 0 degrees Fahrenheit. Again, if you live in someplace colder, you experience that. Southern California, probably not. And so when we think about it through a scientific lens, the real unit of temperature is something where 0 needs to mean no thermal energy. And that unit temperature is known as Kelvin. It gets the symbol big K, and there's no degree symbol. It's just, you're at 300 Kelvin, not degrees, just 300 Kelvin, which I like because, typing on Word documents and stuff like that, it's always a pain to insert that degree symbol. And so again, the reason that the kind of real unit of temperature is Kelvin is that at 0 Kelvin, we have no thermal energy. There's essentially no molecular motion. This is not something that we're able to achieve or have yet to be able to achieve in a lab. We can get very, very close to 0 Kelvin, but we can't actually get to 0 Kelvin. And there's all kinds of crazy predictions of what would happen if you got to 0 Kelvin, because it's, you know, quantum dynamics, or quantum mechanics, and it's all a bunch of crazy stuff. Anyways, just to give you an idea, 0 Kelvin is equal to negative 273.15 degrees Celsius. So you can see it's quite negative on the Celsius, and it's equal to negative 459.7 degrees Fahrenheit. And so let's just take a look at a conversion. Again, I'm not going to ask you to go from Celsius to Fahrenheit. I'm only going to ask you to go from Kelvin to degrees Celsius. So the equation that we have here is that Kelvin is equal to degrees Celsius plus 273.15. And so, for example, if we had 25 degrees Celsius and we wanted to convert that into Kelvin, we would take this 25 degrees, plug it right into there. 25 plus 273.15, and then you get 298.15. And then according to sig fig, since this is addition and subtraction, our uncertain digit is in the ones place. And so this would then round to 298 Kelvin. All right, just one more thing to note, that with degrees Celsius and Kelvin, although the 0 point is different, right? Although when you compare the absolute numbers, they're different, the difference of temperatures is the same. So for example, if you had a change in temperature of 5 degrees Celsius, for example, you went from 25 to 30 degrees Celsius, that would also be equivalent to a 5 Kelvin difference, right? So when you're talking about delta T, which is what we'll be doing in this upcoming section, it doesn't matter whether you use Celsius or Kelvin. It does matter if you use Fahrenheit. Fahrenheit is something different, but we're not going to use Fahrenheit because it's a science class. So when we're talking about delta T, degrees Celsius and Kelvin are interchangeable. So it doesn't matter which one you use because they end up being the same thing. When we're talking about absolute temperature, for example, you know, it is currently 25 degrees Celsius. Then we have to use Kelvin when we're using scientific equations. And we'll see more of this in the gas chapter. So see more in gas chapter. So anyways, takeaway, if it's delta, you can use Kelvin or Celsius. If it's not delta, you have to use Kelvin.